Our next speaker is Augustine Sitati. Augustine is from the Department of Biological Sciences. Title of the talk is Tiny but Mighty, the Story of Algae in a Salmon-Bearing River. Thank you.
I want you to try and remember of a time you were at a river. Chances are you encountered algae, those green strands swaying in the water current, or the slippery layers coating the rocks, quietly providing food for the tiny insects that are later eaten by the fish. Algae is the powerhouse of the river. In the Eel River in California, two forms of algae dominate the river. The filamentous algae that looks like long hair, carpeting the river, and those that grow on rock surfaces, making them slippery to walk on. However, like any other organism, algae require nutrients to grow. This river has very low nitrogen levels. In theory, algae shouldn't be growing much here. It's like trying to bake bread without yeast. The essential ingredients of growth are missing. Yet, the algae thrives. But how? You see, early in the summer season, the filamentous algae grows, forming bright green mats. As these mats age, just like the traffic light, they shift in color from green to yellow to red. And it is at this red stage that something extraordinary happens. The surface of these filaments and the rocks nearby become covered by epithemia, a unique algal species that has a tiny bacterial partner living inside it that fixes nitrogen, pulling the nitrogen from the atmosphere and transforming it into forms usable by the river. My research builds on this discovery by asking, how much of the river's productivity is supported by epithemia? Well, using a technique known as stable isotopes, a way of tagging the nitrogen and seeing where it goes, I found that river patches dominated by this epithemia was doing nearly all the work, contributing about 98% of the nitrogen used by the algae. And that at a rate of about 2 milligrams of nitrogen per meter squared per hour. This is just not a number. It is a significant amount, and it is among the highest rates recorded for rivers globally. But what does that mean for the insects and the fish in this river? Well, I'm still working on that. My research is important because it gives a voice to this important process and shows that if we don't care for the algae, we will lose the salmon. We all love salmon, don't we? If not for our dinner plates, then for our cultural and economic benefits. Thank you.